I can share this while this is opening. But in the meantime, let me introduce myself to those of you who are, I see some new faces in the audience here, and I see some regular joiners. My name is Fatma. I'm a data and AI solution architect here at Microsoft, and welcome to the Azure Qatar community, where we gather weekly to discuss everything Azure and Microsoft products related. This is a community event, so it's not an official Microsoft event. It's meant for us to share knowledge. We had people from different partners and different Azure enthusiasts presenting. We covered things like Azure AI. We're live? Cool. We covered different things like Azure AI, Fabric. We had sessions on last week. Does anyone remember what was last week's session when it comes to migrating projects from on-prem to the cloud? So if you are not part of our community, make sure to join the LinkedIn group and the WhatsApp group. This is where we post all our updates. And we also had Microsoft Build recently happen. There's been a lot of announcements around that. You can check out the link here to, most of the sessions are recorded and you can watch it on demand. We're planning to have a session maybe later after Eid to cover all the announcements and delve deeper into that. We also, okay, I think I didn't update that. Let me just jump straight into it. Today, most of you probably already know Sher. He is our senior data and AI solution architect here at Microsoft as well. And he's going to cover all about
streaming data,
which is an interesting use case for those of you. How many here work with streaming data? Okay. Okay. All right. So he's going to cover a little bit more about what it takes to deal with such data. We're going to talk about Azure IoT Hub and the offerings that are there. And then as usual, right, Fatah, we have our we have 3 mugs to give out. And so listen attentively, and there's going to be questions towards the end. And if you answer them right, you get a mug.
Introduction. I think another one. You have another session for IoT.
Yes, today.
Yeah, this is IoT.
Yeah. But today you were in the wrong room.
The IoT, if you are just seeing that IoT thing, right? I just will clarify.
All right, Sher, on to you.
Yeah. Is there anything else, Fatma, you want to?
Nope, that's all.
Yeah. So the session was IoT related, but actually the IoT device in itself, it needs to have the data needs to come in, because the IoT side, there are 2 parts. One is the device management, which is the hardware side, and one is when the data is sent and you want to build some intelligence out. So we'll cover the data side, which is how the IoT is connecting and then bringing it. I will just show a demo, for example, like a smaller sensor, okay? But we will not cover like industry IoT device management, okay? Because it requires a lot of hardware and gateways and things like that. So we'll not go into that. We'll just see that, for example, once you connect the IoT side and the data is flowing through, what you can do with it. What are the scenarios that you can build new scenarios out of it? For example, fraud detection, how streaming can help with that. So these kind of items we will cover, okay? But it will give you an idea what are the different services that you can use, okay? Even for device management, I'll cover that. But if it's just like the data, because the data might not be coming from IoT data, it might be coming from an application in real time, okay? Like any other, let's say your mobile application, it might be sending data as well. So it will cover both of them, okay? Yeah. Any questions on IoT or streaming side? But the topic is related. I consider it's related. Okay. Okay. So if I before coming to the IoT or anything like that, why do you think like streaming data is required? Like why we need to discuss this? Like data is data. Why streaming data?
For analysis.
Okay.
Live updates.
Sorry.
Live updates.
Yeah.
It's alerted with something goes wrong.
Yes. All of the things. So consider like in IoT scenario, right? When the data is flowing near real time, you can take action. Consider that you are having, a classical example. Let's say you have a freezer or a fridge, and you have, let's say, grocery or components in there. If your fridge or freezer is down, okay, how would you know? All your produce will get rotten because the temperature needs to be maintained. Okay, you will see a lot of trucks which are moving around, moving the grocery and ice creams and everything in there, right? But if they don't know that the temperature is dropping, how would you know? What action you will take? Similarly, let's say your data, your credit card is misused. You are here, but your physical card has been tapped somewhere outside of the things. How the bank knows that, for example, there is some fraudulent transaction. Okay, so all of these things can streaming enable this, because the time when the event happens to when you respond will reduce. You don't have to wait for 15 even or 20 minutes or a whole day. You can take action instantly. Okay, let's say in an aircraft scenario, you would have seen like Boeing has so many sensors, but if the sensors are not working, how they would know that, for example, this thing is gone wrong and the flight can goes down as well. Okay, so this helps with the information accordingly. Just to start, okay, we will build just a simple architecture as we usually do. Okay, just so you guys are aware what it means, and then we will connect the components accordingly. Okay, but we've already covered this, that you will have lower latency for this kind of data. Okay, when you are ingesting, and let me see. Okay, so you can see here the real time. You can do it on the edge, local, anywhere. Okay. Near real time, local to the cloud, millisecond to minutes, like it depends on how you can process it, right? Sometime when the event is happened, right, that you will just say it might be a fraudulent signal, or it might be like a disruption in the temperature as well. So you will just say the freezer example that I have given you previously. I've worked with one customer like this, and they were just saying, we want to see that if the temperature drop for 1 minute continuously below a certain threshold.
You are not sharing your screen.
Yeah.
I believe Fatma
Okay.
presented, and then can you reshare it? Yes.
Let me know if it's. Yeah. So when the temperature goes down for, let's say, 1 minute, then you can take an alert. Otherwise, it might be like some fluctuation, and you can take like a false positive as well. Okay. So this will help you, like some of the things that we were discussing. Sometimes it depends on the application. It might not be milliseconds. The data can come to the processing area much faster, but you might take an action after a minute. Okay. Why the clicker doesn't work? So this is just again like on the streaming side, as you mentioned, right? This is like sometime when the data is coming, you would like to visualize data, right? Like the traffic management system as an example. You want to see the buses, like even if you see like your apps like 𝗤𝗏𝗏𝗏 or Snunu, you just see like a real time that the person is moving around. So that is the telemetry that is coming from those devices or like vehicles as well. So you just send the streaming data to an app to visualize for the end user. Okay, you can also store that data for historical trends, okay, for long-term retention. And sorry, this is the human eye. Like for example, if you want to visualize something on the notification and everything, you can do that, and you can send it to application to take an action. Okay, like as you're maintaining, like if there is a fraudulent transaction, you send it to a system. The system will take an action. Okay, either block the card or call the person or do something else for verification. Now, from data source point of view, right, it can be anything. Okay, it can be a device on the cloud, on the edge, or like a sensor or industrial sensors. Anything we can. You will see a lot of IoT sensors that we have here as well. Okay, but they send the data on a particular frequency, and that is where the IoT connectors come in. Because consider you have 1 million devices. How would you maintain it? If somebody asks you how many devices you have, if you don't have a registration process, that's the where the device management comes in place. And that is the tool usually, like you have to register these devices. And you also have to do like authentication of that, because the devices, nobody can send the data to your streaming platform. You have to make sure that they are registered devices and you can control them. Okay. Then there are some scenarios in which we require a unidirectional data. from the IoT to the platform. In the other case, you want to manage, like let's say if you have an IoT device somewhere in your industry, you would like the software to set or reset the firmware or do some action accordingly. Okay, you will not like go to physically a particular, let's say a mine under, let's say, a kilometer, and then you just like physically fix it. You just maintain with a signal, right? Like that's what happens. Like even the cameras and everything like that, you can see that accordingly. So the first thing in the architecture, I'll just pick mostly this architecture. But usually when the data is flowing, we usually store that data. But in IoT scenario, we usually first queue the data. Why do you think that will be the case? Why we cannot store it to, let's say, a file system or database? We store it to, let's say, a queuing system like Kafka, Event Hub, IoT Hub. We store it to some kind of queue. Why is that?
Process delay.
Any guesses?
The arrangements.
Because if you look into the IoT data, there is a velocity. Okay, the velocity is so much that a normal IO system will not be able to handle it. If you store in the database, the IoT sensors, you want to send it as soon as possible. So you want to send it to a memory rather than a disk. The disk will always be slow. Okay, so if you send this data directly to, let's say, a file system, you will choke the file system because the data volume is very, very fast. Okay, if you send it to a database as well, it is not like a bulk stream coming. It is just constantly coming. So a database will be always just inserting the data. It will not be able to do anything else. Okay, so that's why these queues are there, which is like, for example, if you are aware of Kafka, okay, it's one example. In Microsoft, we have Event Hub and IoT Hub. Okay, these are queues. So it just creates like an in-memory transient system which can send the data and it will just store it for some time. The some time can be up to 7 days, okay, or even 30 days. But then the consumer need to decide when they can pick it up. You will like to take an action or something like that, or you want to maintain it, you can do that as well. Okay. There are two solutions here. Like you can ask me why two. Okay. The first one, the Event Hub is just like a unidirectional. You just take the data and it's registered. It will send the data to this Event Hub. Okay. This is like a normal Kafka thing. Unidirectional data will just flow through. You will not be able to send anything back here. The first one, which is IoT Hub, this is a device management as well. It has queue and it has a device management as well. You can register million of your devices, okay? And then you can even set commands from the, like consider that this is a control center. That can send commands to IoT devices which can receive or which are capable to receive, let's say reset commands or anything, update commands or anything else that you want to do, that can send the signals back to this one as well. Okay. Any questions? Yeah.
I have a question. So for, as you said, that it only save the data for some time. So for instance, if we want to, I mean, we have an analysis that we want to get history data. Maybe we want to compare the history data with the current data. So in that case, it's saving the old data in another place and the current data is allocated here. How do we justify that?
So very good question, but consider that this data you cannot join or combine with the historical data that easy. Okay. If you want to do it, consider that you have the device data is coming and it's just giving you ID and let's say temperature. But you don't know, for example, million of IDs are coming. What is the actual device name or what is the location of that device? Maybe the device is not sending the location. Okay. But you have a lookup table or a lookup mechanism that you know, okay, this device is located, let's say in Lucille, in this particular building, you have that metadata. Okay. So you can do a join, like you can have a mechanism that you can update a file or something like that, but it will be brought into memory as well. It will just provide just a join at runtime, but it is not like you can have millions of rows. It should be a smaller set. There is a restriction how much data you can brought in for join in these scenarios. Okay. But historical data, if you are doing it, then you have to make sure that this data is not that fast or not ingesting that fast that if you are doing a lookup, it will take like ages or it will choke the system. So there needs to be like a balance between in there. But I'll come to the database side in a while. Any other questions?
Yeah. What's handling the communication between the IoT hub and the devices?
Yeah. So usually there is different type of protocol, right? Like this communication can happen on HTTPS. Okay. If the device are enabled with Wi-Fi or any network, as far as the network connectivity is there, the device has a mechanism that this is the the protocol it can support. If it's an HTTP, usually their firmware has an ID that you can just put the connections in there, or you can just connect that this device is connected to these services and authorized. And this can happen like on local network or like Wi-Fi or anything. But it needs to have that mechanism to be able to connect to this system. Now, if all your IT devices are not internet connected, then it needs to have some mechanism that how these devices will be in there. That's why in the middle, usually, there is a gateways. These devices send the data to the gateways, and the gateway then communicate to these. Okay. The gateway is like, I'll just give an example in here. I was working on one project in which they wanted to stream the CCTV cameras, and they want to analyze this. Now, the devices were not able to send the data in real time to these devices because even the security mechanism doesn't allow this. Okay. So what they were doing is there was a gateway server in here on-prem, and these were constantly sending the data because it was a packaged solution by some company. Okay. They will send the data to the gateway, and then the gateway was exposing APIs in real time in which we have programmed that this will be able to send to these devices. Yeah. So once the queue is there, then you want to do processing, and this processing can be in two ways. Okay. One is that you look into individual event that is happening. Okay. So consider that you are looking for some event that a fraudulent transaction has happened as a result. Okay. And the individual record is telling you that there is some event has happened. Okay. You don't need to combine it with another event. Okay. So in this case, you can just use like a any computer. Okay. Right. Like it's just like showing Azure function, but it's like you run a Python program or a C# program, and you just say that this function can be triggered whenever there is an event coming here. Any time you receive a message, trigger this function. And every time it will look into that. And then if you want to process something, you can do it and then like pass it on or drop it according to your need. Okay. The other thing can be that you want to analyze the stream of data. Okay. Like one event has a relationship with the other event. In this case, you need to do something like, for example, streaming analytics. Okay. It can be done with Spark streaming or Storm streaming or anything like that. But in here, I'm using Microsoft Service, which is Azure Stream Analytics, which is easy to implement, and it supports SQL database rather than Python or Storm or any of those languages. So you can use it directly here. Now, in here, you can define windows because when you are saying that I'm here and the data is keep on coming, right? You will just say, I define a window. Look into the last 5 minutes. If I have done a transaction, let's say here, and the next time the transaction is going into, let's say, US, if there is like a 1 minute gap or something like that, this may be a fraudulent transaction. Or, for example, look into the average of the last 5 minutes because you will define a window. You cannot look into the whole history. You will just say, look into the last 5 minutes for a particular IT device and tell me what is the average temperature. If the average temperature is going below this, that means something is wrong, alert something. Or you just say, a device is not even sending a signal. You can just say if a device is supposed to be active and it's not able to send the data within the next 1 minute to 5 minutes, okay, raise an alert that the device has some malfunction and it's not able to send the data. Okay. Any questions till now? Is it making sense?
All of that could be done without going to a database because we use the
Exactly.
a system to go to read the data from the database and then trigger the action.
Yes.
Here it will not be like that, just it will reach to the IoT hub, for example, it will trigger this thing.
Yes, because as I mentioned, you can do with the database, but the database is first you are inserting the data which is IO intensive, okay? Then you have to pull the data because you need to look into it, what everything is doing. So you again have to read the data, and it will be again another latency problem for you for IoT scenario. So in here, everything is in memory, considered as in memory, and that stream is just looking into the memory, but you just shorten the window that I want to process something in a shorter window time, and I just want to take an action after. Okay. After this, what should be a logical step now? Once we have like this thing, like this can, for example, from here, I can send an alert. If something has happened, I can send an alert. If, for example, this is here, I can have an alert. But what are the things I can do?
Either action or dashboard.
Yes, because
Dashboard.
yeah. So there can be multiple things, right? For historical trend, I can save this data to a database now. Okay. But the database, what I'll do is I will have two mechanisms. There can be any database, right? You can put it in Postgres or SQL, Oracle, any database, all the database supported. And then there are specialized, so like databases which are time series. Okay. So a time series, you can select that because it will have like more different type of functionality that it can provide. But consider that you are using, let's say, a NoSQL database like 𝗥𝗲𝗹𝘁𝗶𝗺, which is like providing you lower latency in insertion. Okay. So it is very, very fast. And also like you can have a long-term retention, which is like the Data Explorer. This Data Explorer, I'm using one of the component, but this is available in 3 different flavors. We call it in Synapse, we call it Real-Time Hub. We have in Fabric Real-Time Hub, in Synapse as well, and as a separate service as Data Explorer. So consider it as analytical or time series data analytics solution. Okay, this is a database, but it can process very large volume at very fast pace because it's specialized for those queries. Okay.
Because I also know that data that are retrieved from a streaming data are not in the structured form. It will be semi-structured, whereby I mean there is no need for arrangement.
Agree. So that's why if you see the Cosmos DB, mostly it's a JSON structure. So you can put JSON directly in a things, and then you can do queries at runtime. Similarly, in here, you can do the same thing. Usually, the IoT data is in a JSON, like in a deep structure. There is some structure in there, and then you can do the JSON here. Okay, in one table you can land it first, and then you can automatically trigger to even parse it to for example, you extract some relevant field for the JSON for faster retrieval, and you keep the rest of the items in a JSON form. You can do that as well. Okay, but the initially I said that there will, if you put the data into these databases, you will have latency problem. But again, I'm storing here. Why? Like how if I'm storing in a database, why cannot I do it directly from here to here?
Because you want to do an action in the after processing.
Okay.
You want to be able to have something event-based after processing.
Yeah.
Because storing takes time.
Yeah,
So
sure.
you want to take advantage of that.
Great. But there is one other reason as well. If I can do, for example, the other thing can be that here I'm just reading it very, very fast. Like in 1 second, I can get millions of records. Okay. But in here, when I'm inserting it, I can do as well like the same thing, but I define a window. Okay. Because these are all processes. I'm just saying that after 5 minutes, insert the data. After 15 minutes, insert the data. Rather than then every record when it's coming, because the database are not built for that. Okay. Yeah. So I will just say that, for example, from here, create a batch of 5 minutes window and then aggregate it and send it to these databases. Because I might not be interested in the individual records afterwards. I just want to aggregate it and then do it. So consider in 1 minute, let's say if I get 1 million record and I summarize it based on the devices, it might be just like 10 records per minute as an example. Okay. But some company will also like to have the raw data stored as well. Not in the database, but maybe as a like archival system. Okay. So just to let you know that this kind of system can have automatically like a link. Okay. I can store this data on Azure storage as well. Okay. But I just defined the functionality in this system are also there that I can directly store it to file system, but I will just define a window. Don't store the data as raw, combine it for 10-15 minutes and then write one file. Okay. Sometimes the customer, they just write the files very, very small, like they write the file every minute. And then we have another problem, which will be the small file problem. You will actually end up with millions of files. Okay. With millions of files, when you query it, the query will take less time, but actually the list of the file will take minutes. So again, it is very like problematic that you cannot even list the files. And this is like a real problem. Like a lot of people send a file and then you don't know how to aggregate it, how to list it, because it takes hours just to list the files, because you are querying the files in millions just from a non-optimized storage account. Okay, so this is very important that you take this decision when you are designing these systems. Okay.
Who is like a storage space?
Yeah,
right?
in memory, yes. Yeah.
So it's in memory.
Yes. It is memory. There is no like physical things. If you want to do it physical, you can do like this, or you can do like this, but it can retain data up to 7 days. Okay. But depends on how big you want to pay. The more data you want to store in memory or partition, the more costly it will be. Okay. And then the last thing is what we discuss as well. Sorry. Back. The last thing is the visualization, right? Sometimes you would like to have real-time alerts or monitoring, or like how we are seeing like the car is moving or the ambulance is moving and things like that. So that can be done in there as well. Okay, there can be multiple visualization tools. You can use Power BI or any other thing, but mostly Grafana is used for this kind of real-time streaming visualization. It has two very good capabilities. Okay, and similarly, like Azure function I have added, in case this function you want to trigger something, sometimes you will just put the, rather than triggering it from here because it's like a processing system, you put it again on another queue. Okay, you put the thing and then there is another consumer who just look into those kind of triggers. So just not confuse it. Okay, so it can be a chain of this will become then IoT. You can put it here. Okay, in another event hub, not in the same event hub, but in another event hub, and there is another processor which is looking into this. Whenever a fraudulent transaction happens, I'm the one who is supposed to handle this. So it's just like doing it modular. Okay, any questions now? Once you understand this, you will just like all the other architectures are very simple.
Yeah, relating this with Google Map. I mean, you're driving and from Google Map on the dashboard, you're able to see that after 2 minutes there is traffic. How can we relate this?
Yeah. So if the map is here, okay, the map is usually like you will have an API that you can update. Okay. So as far as the data is sending and you are just updating the map, it will just keep on sending the data and it will update the map accordingly. Okay. I can show one example. Like we can show one example. When I do a demo, I'll show one example. Okay. Yeah.
For example, let's take a simple use case: temperature of a room. For example, if it is below here, like warm it up. So where does the action comes back? It's in which case? So let's say that in the data source we have the sensor of the temperature.
Yes.
So it sent it to the queue.
Yeah.
In the processing, the Azure function, I have a code. If it's below like this, please send it back to there. So it's
send it back to where?
Send back to another sensor that I have to turn on the AC.
Yeah.
For example.
So this is what I said. Once you have this one, okay, you can take the processing from here and directly send it to the other system. Okay, or you send it back to here, and then this is like another agent which is like calling the API of the AC that the temperature should be reduced. So as far as your AC has another control that it can be called from a system, it will do it. Okay. So let's go into one other architecture. Okay, just so you get used to this symbols and the Lego pieces. Okay, there's another use cases in which you have streaming data or IoT data. Okay, it is sending it to Event Hub. Okay, it's ingesting. You will never see any streaming platform which don't have like a queuing mechanism or ingest mechanism in between, like in memory. Okay, then from here you can see that I'm sending it to two areas. There is a storage which is just storing the data in a raw form. Okay, and this is aggregated. We will have to provide an aggregation like 5 minutes, 15 minutes, 30 minutes, and then it will create the files accordingly on the storage account. And you will partition it. Whenever the data is coming, you just do it in like YYY, like this, based on your own thing, because you want to reduce the number of files. And then you can have another processing in here just to combine the files after like a day or so. Okay. And then
you're partitioning and aggregating at the same time?
No, I'm partitioning and saving. And then I can have another processing in here, which is looking at a batch at night time. I'm just aggregating like the last day data to combine it and removing these files, because these files can become at some time too problematic. Okay.
Is there like a use case scenario where people would basically, instead of deleting them, just archive that?
Yes, archival is also possible, but the main thing is that the data is so much that why would you archive? And the archive you cannot retrieve it. It is again a lot of IOs and cost in there as well. Okay, one thing you need to be aware of okay, let me ask this question. This file, what should be the format of these files? Why Parquet?
Just metadata storage size, retrieval.
Okay, but Parquet is good for columnar type of thing, right? The data is very, very small. It is like not like aggregated. So do you still stick to Parquet? Not JSON. JSON will be too problematic.
There's another one called use.
Yes, 𝗥𝗲𝗹𝘁𝗶𝗺 or ORC. These are the formats which store into a raw form, because you don't want to have a columnar or aggregation in there. So by default, usually you can save it in Parquet. There's no problem. Okay, If you are running a query on top of it in Parquet format, you can do it. But by default, some of the system will do it in Avro or ORC format. It will do because it's a row-based form. Because the compression will also take time. Okay, so just be aware of this. And this, just as a side note, this a lot of time comes into interview questions as well. This file formats. Okay. Yeah.
Also, JSON file is not supported.
No, JSON file is supported, but I'm just saying that the JSON file will be individual files. So if you want combining it or aggregate, like combining 5 minutes, how would the JSON look like?
So it doesn't correlate. I mean, if you want to correlate the signals, it's better without JSON.
Yeah, the JSON is fine. Like if it's like in one JSON in 5 minutes, you can just define. I'll just show example. JSON is supported, Parquet is supported, ORC is supported. You can do everything. But I'm just saying on your use case, you have to define which is better compression. So the data and everything, like the retrieval and everything, you have to think about everything, right? What you need to do. But you are right.
Use case scenario. If let's say 1 hour, I will receive one signal, for example, we don't have any problem with JSON.
Yeah. The JSON, as I said, that the source of the data is usually in JSON format. So you want to retain maybe in the same format, but it's a lot of time that they want to query, people want to query, or that structure is not very JSON structure. It is like multi-array structure. So you want to transform it before even storing it. Okay. So a lot of time, if the raw data is not required, okay, what we do is we first stream the data, we select the relevant field, we aggregate the data, we put it into a right structure which is optimized for my retrieval, and then from here, I can send it back to the storage, I can send it to a database, and then I can query accordingly. But this is just considered that it can send the raw event just a pass through, or it can just do like aggregation. So you want to reduce the data or like parse the data which is not in the format that you require. A lot of time, I'll just give an example. I work on one of a use case which was clickstream data. We were getting 4 terabytes of data set per day, okay, compressed. Uncompressed around 40 terabytes. Okay, and we use this kind of mechanism in there. But consider 40 terabytes. If I just put in the storage was choking. Okay, and then I have to like aggregate it. I have to do different techniques. Even different database was like either if I scale it to a very large limit, the cost was unbearable for the customers. So I have to like then use the real-time data explorer, which I told you. That was giving 1:100 ratio compression. So the 4 terabytes will actually become 400 MB or 4 GB. I don't remember the number, but there is an article I have posted a blog. You can have a look into this. I'll show it. I wrote it 5 years back, but still relevant. And then, for example, there are different databases, right? This can be different use cases. You can set some data to the IoT stream or like the Cosmos DB in JSON form. So your application is there, or you can just have like some reporting on top of it. So the reporting is usually in a structured format, right? So you would like to support it in a relational database rather than a NoSQL database. Okay, but it's your choice. There are so many Lego pieces. You have to decide which one you want to go with. Okay, any questions? Yeah.
Can we, before we store the data, just select some matrix or dimensions to be stored instead of just storing everything?
Yes, that's what I said, that you need to see what you want to do here, and then you just send the relevant data or aggregated data. If you just pass everything, you will be like you cannot maintain how the database will cost. Okay, so that's why a lot of customers, what they do is, for the relevant use case or the known use case, they send the aggregated or a relevant feed. They just put it here, and then for historical or long term, they just use this path. They just store the raw data here, and then use some like Spark or Databricks or Synapse or Fabric, and then they just provide analytics on top of it.
I mean, in the step of the blob storage itself, can I do that queries here?
Yeah, you can, but the main thing is whether you want to store the data after you aggregated it to like a database or a blob storage. It's up to you. You can have everything, but sometimes the customers say that the stream data is like a one time. You cannot repeat it. So if it's gone, it's gone. Okay, so some customers say, I don't want to take the risk. I want to store the full picture, and then I can do it. But in some example, it's not even possible. As I was explaining, the clickstream data that I work on, it was 2,000 fields. 2,000 field, a database will not even be able to store it. Okay, a database is usually like a couple of tens. After that, it will just like go wide. Okay. Any questions? Did I clarify? Yeah. You can do whatever processing you need, but you need to decide what field you need, how much aggregation you want to do, whether you are losing any information or you can still retain it or retrieve the information accordingly. Okay. So I'll go. There is a lot of customers. They don't understand how to do like the event hub properly. So I'll just explain a little bit more detail and I'll then show a few demos as well. Okay. But we will go into two parts in a bit more explanation. I'll just put event hub and streaming. And then I'll just give an example of IoT hub replacing this in a demo. And I'll just show one with my mobile as well. Okay. But here you will see that it's an event hub. Okay. It collects sensor at scale. Okay. Process real-time data, smart city, industrial monitor, you can do everything. Okay. And it can scale to a very large number. Just consider event hub as a Kafka. Okay. You can also see that it's application logging can be done. Okay. If you have like a customer usually build the individual applications and they are saying when the application get crash or something like that, they want to retrieve the signal. So that telemetry can also be considered as real time. Or for example, if the user is, let's say you are on a particular app, you are doing clicking, it's sending the data, it can do real time offering to you as well. Let's say you are on a grocery site or something, you are buying something, it can recommend something real time and that can be enabled from here as well. Okay. So the use case we already discussed, right? Real-time ingestion of the data, it can have anomaly detection because anomaly is what can cause fraudulent transaction or something like a irregular behavior. Even on the sites, you have developed an app and suddenly the usage spiked. Okay, now you need to think about how to scale your application, whether you want to your application will go down if you don't take any action. Okay, but these are all the different actions that we can have or use cases that we can have. Now, this is important. If you like, we were discussing about the protocols, right? Yeah. This is mostly like the protocols. You have to decide what protocols you are supported. For simple cases, we usually use HTTPS because it doesn't maintain the history individual stream, and you just post it and then you forget about it. You don't know whether it was received even or not. But in streaming cases, you can take the things like every signal. Or every message is not important. If some message is even dropped, you just say, okay, the next event is coming in a while. Okay, so it's okay. Then you have AMQP. This is another protocol. A lot of applications use that and just like stream the data, it's much faster. Okay, and then the Kafka as well. These all protocols are supported. Now, what you need to do is in the event hub, this icon when you see it, it's just a namespace. Okay, just consider that it's a blank or a database. Okay, and then under the hood there is tables. The event hub, individual event hub is 1, 2, 3. You can consider this table, and then you can send your data to any of these. Okay, afterwards each table is partitioned further, and the partition will decide how much throughput you can do. Okay, how much data can be done. Consider that one partition. Sorry if I'm wrong, but I'll check the data. But consider one partition. Okay, one partition here, you can ingest 1 MB per second and 2 MB per second egress. Okay, ingress will be 1 MB and egress will be 2 MB with one partition. You can have multiple partition accordingly. Yeah. So ingress is just like the data coming into the system, and the egress is when the data is leaving the system. Okay, so a lot of time the default I've seen a lot of customers in which they provision the event hub, but they don't know what should be the size of it, what should be the partition, and you say we're getting throttled. You promise that it's like scalable, we are just putting compute, we are just costing, but it's not there. So I just say, have you done the right partition? They said, what is partitioning? So the partitioning, if they don't know what partitioning is, or if they haven't read the documentation, of course, there will be problems. So you need to provide the right scale, the right partitioning, the right input and output, okay? And then you can size it accordingly. Okay.
Do you partition based on the data? Based on the data content?
Yeah, you can partition on different way. Like you can partition usually if the data you don't want to retain, let's say the order in which the events are coming. Okay, you can do round robin. Okay, if you want to say that no, that data needs to be in particular order. I want to receive this in the like if 1 second is out or before, I don't want to do that. Then you have to send it to the same partition and things like that. You can do multiple things accordingly. Okay, but there's different techniques on each and every one how you want to do it. But first in, first out. But if you are doing like a round robin, the same data can go to other partition, or the same IoT sensor can go to multiple partition, and you will not be able to join it, or you will not be able to see it because the stream will or look into individual partitions. So make sure if your data has, you want to relate one event with the other, the same data or the same IDs are put into the same partitions. Okay. So this is just an example, right? Like any n partitions, okay, you defined it, you will fill it up. The data, the consumer can then read it accordingly. They will put their own watermarks, and I'll just explain it accordingly because the watermark is very important. Okay, Event Hub as an example, or the queue will not maintain its own watermark. It's up to the consumer to retain till which point they have read. Okay, if their point is their watermark has reset, they have to like go back maybe or restart it. They might be receiving duplicate events. So you have to think whether your downstream application is okay for duplicates or not, and you have to make sure that your consumer can handle that those kind of scenarios. Okay. If the watermark is the same, it will keep doing incremental, but sometimes reset can happen. You will just say, oh, my system has received duplicate records. Okay, but you have to think about it, how you will handle this situation in streaming data. That's why the streaming data individual record doesn't matter. If your application is such that you want to do a messages from one system to the other and each message is individually too important to be dropped or duplicated, then use other mechanism like service bus. Okay. There is other messaging system that you can use as well. Okay, but is this clear? The producer will send the data. It can be like Event Hub, the IoT devices or any application. It will select one of the protocol and will start sending the data. The data will be, they will define how they want to partition, whether the round robin and everything like that. They can select a particular partition, but if they select a particular partition, it can make that partition hot. Okay, but if the application is already know that this is what we are doing, then it's all good. Like they can do like the application is up to the application how they want to retrieve it. And here you can see there is multiple consumer. Each consumer is reading the data on its own pace. Okay, because that's the beauty of it. If let's say Fateh and I are the consumer, okay, Fateh is fast, I'm slow. Okay, so when the data is available, Fatih will read it and I'll just come after 2 days and I'll just say, okay, now I'm ready to do it. So it's up to the application. That's why you retain it for some time. The 7 days that I told you, you define how quickly the consumer can do it. If the 7 days pass and the consumer have not picked it, it's lost. Okay. How we are doing with time? We have 30 minutes. 45. But there's always stuff. Now we cover Event Hub, right? I'll just give you some points. So at least this was the basic session I want to start, because if I go too deep dive, I will lose you guys. So first you got some basic, and then we can have a longer series, like we can have demos and different type of solutions. The other thing, as I told you, I will just cover one compute, which is like stream analytics. Okay, stream analytics. Why I like it, because the integration with the service are very easy. Okay, you can see this kind of SQL. If you are aware of any SQL database, okay, it just says from factory floor stream. Okay, this from will be your IoT device. So the IoT device become your table. You just say select, then whatever we were deciding, like whatever columns you need to do or whatever information, you just say equipment ID, average temperature. Okay, this is the average temperature of an equipment from the Event Hub into where you want to send. So you want to take some alerts, so you can just send that system in here. It can be a reports as well. It can be a dashboard. You just say that the notification hub or the notification bus, you want to take an action. And then you just say group by tumbling window. You just say aggregate the data for 1 minute. Okay. And when this data is larger than 75, okay, then I want to do some action. Otherwise, drop it. I don't care what happens. Okay. It's just a monitoring stuff. Does it make?
This one is done in the action phase.
Yeah, in the processing. So you do this query in the stream analytics, the compute. You remember the previous architecture which we said? So you have the data received, but then every minute you are running this query. Every minute this query is executing. Okay. As well, like, let's say if you have, let's say, even 1,000 of event equipment IDs, which is above this threshold, it will send all of that data to the next stream. Okay. So afterwards, let's say you put this in the database. Let's say you didn't even take token notification. You put in the database. The next day you can say how many equipments were above this temperature for how many time. So that will, you can create this kind of dashboards as well. Yeah. Or the same thing like Talabat thing. You just say how many deliveries were delayed or how many were not in the first 30 minutes. You can just use this kind of in there. Yeah. So again, the same structure we have previously, but like you can call it even broker or queue or anything like that. Even have the same thing. Okay, this is the data. You asked a question about reference data, right? This is what the reference data is supported. There are two reference data you can have. You can have a CSV file or an SQL database. Okay, but this file has limitation. Like you can not have it in GBs or TBs. You need to be a reasonable size. Okay.
This one's two direction. Engagement. That's mean is Azure Stream Analytics taking also data from the SQL?
Yeah.
Because I'm expecting it will take the data which is coming from the IoT devices.
Yeah.
Running this SQL statement, and the output I will send it to the database. But what I'm going to take from the database?
Yeah. So considering here, if it's reference data, it will be doing like this: select star from input, join with this reference data. You remember the example I gave you that the IDs are individual IDs. This is individual IDs. This is the temperature. But you want to see where this individual ID is located. The location data will be here. So you will do a join. Okay. And the other thing is you can have like a machine learning models as well. Okay. The machine learning model, like let's say you want to, you have seen the data, but you want to predict something, which is not like a query rule, but a machine learning model, a predictive stuff. So you can have the machine learning models in here and you can expose that as an endpoint. So it will automatically call that. Okay. Yeah. And you can say that, for example, for the last 10 minutes, these are the events. Can you now tell me whether I'm on the right track or not? Or like, let's say the temperature is increasing. Will I have an outage on my device? So before even the outage can happen, you can take that a machine learning model that yes, you are on the root cause. Previously, this thing has happened. So before even you get a signal that this device is going to be broken, you can do a predictive maintenance as well. So the machine learning can do that intelligence. And then afterwards, you can send it to anywhere, right? As I was mentioning, if you take an action, you can put into a service bus or database, okay, and have an action on top of it as well. Okay. If you want to take some other thing, like you want to notify someone, like SignalR as an example is on the mobile app, you will see a notification. Okay. Like similar to like if you are playing with stock or something, you will just have a notification that this stock has gone up or down and things like that. So that's how they are doing it. And then for long-term retention, you can have it here. For archival and everything, you can have it here. For dashboards, you can have it here, the real-time value. Okay. So yeah, any questions now? I'll just use a few slides and then I'll go to demos. Okay. I think the concept is clear, right? Like you can have in streaming jobs, we can have individual jobs in which you can just run one query, one input, one out, or you can have a cluster and you can run multiple jobs together. Okay, so that's a dedicated cluster, and the other one is like a standard cluster. Okay. It's the same. I think we already covered this, but it's just to give an example of a query that how you will do joins. Okay, we were discussing that there is some transaction coming. Let's say transaction are coming. Let's say you have getting the IoT data from the point of sale. Okay, like you go to Lulu or Carrefour, you do a self checkout or things like that. That is the transaction that is coming. You want to match it to a product. Okay, and then you want to take an action. You can do that. So this will be a query for the join. We say that this is like the location thing that we are seeing. You can just say with join, select transaction, this from product on this, and then you from the product table, you can have the extra fields in there. When this is matched, when these two are matching, that means take something action. If it's not matching, take some other action. That's why I like this this platform, because it makes our life very easy for the programming. Otherwise, I have to do a lot of. But let me show that in my portal. Okay. I think if I'm doing a live demo, it's okay, right? If my name and everything appears. Like my login and everything, like the top part, my name will be appearing, but it's okay, right? Just give me 1 second so I can switch it. First, what I will do is I will use my mobile as an IoT device just to give the concept, and then we will the next step. There's another service which we call IoT Central. IoT Central is usually easy that if the IoT device are authorized or like a partner solution from Microsoft or something like that, the integration become very, very easy. You just have to come join that and that will become very, very easy. Okay. So what I'll do is I'll just show you first IoT Central. Central application here. Let me move it to my screen because it's very slow there and I cannot see it. I have not like I don't want to duplicate my screen. Just give me 1 second. For one example, okay? Just consider you want to have water utility, let's say any smart meter which is sending the data. You can have like real-time telemetry. It will just show the flow. If there is any chemical increasing or like pollution in the water, you can have it from your tap and everything like that. So just showing that kind of mechanism that where the sensors are located and things like that. Okay, so just an example, very simple. Okay, I'll just go with my phone now. I'll just see there is an app if you have played with it. Okay, it's called IoT plugin. This is the app, okay, which connects to the IoT Central. So I usually for demo it's very easy to do it. So I will just connect it here, and I'll just show the accordingly. Just give me 1 second so I can open it on my computer and then I can show it easily. I've seen the notification that you want to use your location. Okay. So if I allow it, okay, then it is sending, like I'm just showing the things. It has multiple sensors. One, my GPS location is taken from here. The other thing is accelerometer, gyroscope, magnetometer. Okay. If you see here now, we would have seen like the covers. When you drop it automatically like export. It is because of these sensors, the same signals. Okay. Because these ones, if you drop it, it will know that, for example, which sensor is getting dropped. Okay. Even if you just like see the aircrafts, the automated aircraft, it automatically moves as well. It's because of the same orientation that they use these sensors, and that's how it tracks where the movement is happening. Okay. It's just showing my battery, whatever is it showing, and it will show on the computer once I connect this as an IoT device, it will just show that as well. Let me go to the device. Sorry, I was too busy, so I didn't prepare the things. It was a day before I prepared everything, and now I forgot which one I have to show. Just give me 1 second. I'll just show this one, okay? This is my just streaming the data. And okay. So you can see, where am I? I'm near almost like Lucille. Okay, this is my location. This is the battery, okay? And if you see here, you will see I'm just moving my hand, but this will be appearing here, like these multiple things. So you can see even like in the footballs now we have sensors and just detect how fast the kick was, okay? What is the speed of the ball, okay? These all are coming from this kind of IoT devices, okay? Like even if in the boxing, you can just have like the gloves can have IT sensor. It can see that how much was the impact from the gloves. If something is wrong, if the arm is not moving, they just detect all of these telemetry. Okay, but just to give the concept on the top, it just says my name. It's connected, and I can do one thing. Okay, what you can do is if I go here, I want to just show the two-way communication as well. Okay, so if I go here, I can put a rule. Example, the rule can be send email when my model is upside down. So if I just move it like this, it will send an email to me. Okay, I can show the emails, but you just believe me. Okay, so you can have that alert. And the other thing is if I just show jobs, I'm just giving an example so you guys can have the concept and then we will go into the architecture. Okay, I just need to, if there is one thing. Jobs. And I can do multiple communication. Even I can use the computer to enable, or let me go here if I can do this. Where that is. There is a way even turn on. Let me move it back because I cannot see it and I can. It's very, very slow on the screen. Give me 1 second so I can quickly check and then I can come back. Check. Couple of minutes, just give me. So just giving the concept, right? Like as I was mentioning, the two-way communication, although it's not IoT hub, but you will get the concept. Okay. So I'll just say duration, and I'll just say that I can play light on. Okay. You can see light is on now. Do that for 3 seconds, and it will then. Okay, it's off. Do it 3 times. So if the light is, let's say, on the middle of the river, like the sea, and you want to like blink it, you can control it like this. Okay. Now what we will do? What I'll do is this is another sensor. Okay, MX chip. It is called MX chip. It was a famous device that we had like a few years back. It has a lot of sensors. The same thing like gyroscope, magnetometer, accelerometer. Okay. There was one demo which we built. We put it on a toy car, and then we just like run it, like move it fast. Although it will not give you acceleration, but it's accelerometer. It's just like say which axis is there, and we were just calculating that in case you want to do something with insurance, how good is your driving? The insurance company can say that okay, you are a bad driver. Your insurance premium needs to be up or lower. So it's just an example to make it real. Okay, And then the same thing, you can just show it in a dashboard. I will just see if I can make it. But what I'll do is let me duplicate my screen because it's difficult to work. Because all my other windows.
To duplicate your screen, you need to reshare it.
Yeah. Just need to do it on my computer because it's very difficult to do it on the screen. Let me connect here. I'm currently connecting the device, and there is a firmware you can, if you see the documentation, yeah, in the documentation, there will be a procedure how you can update the Wi-Fi password on this device. You can buy it for, I think, $10 or $30. I don't remember, but you can have these devices. And there's multiple devices that you can buy, even the smell device and things like that. They are all in the market. Let me now go here. I'll share my screen, but I just need to go to the right screen. Duplicate. Work. Okay, so I'll just use this one. So the first thing what we will do, okay, I've just connected my my IoT device. I'll check if it's going to connect to Wi-Fi because it sometimes takes a few minutes. I'll just reset the hotspot. And then I'll walk you through the. Okay, but just consider that you have the first thing I explained to you Event Hub, but I'm just going to IoT Hub first. Okay, this IoT Hub is like your device management as well as queue. Okay, you can see this, right? Yeah. So you can see just a while back I was just having this. You can see 42 messages was flowing through to this device in real time. And then once this is happening, okay, this is the queue. So consider your devices are connected, okay? And you authenticate everything, the security and everything is in here. You can define this, manage the device and everything in there. And then afterwards, once you receive the data, then you can go to Stream Analytics. Okay, I'll just select one example. I'll first show this and then we will execute this. Okay, but the beauty is that you can click here. Okay, this is just add as an input. Okay, this is my IoT hub, which I just say add input, and I just connect to that. It will authenticate to that because it's in the same environment. Okay, and then you will show you this connectivity and everything accordingly. Then you just see like the query. Okay, and you can see that I was trying to extract this data. Okay, so what I'll do is I'll just show this data to you guys. Okay, this is how the JSON is coming into the system. Okay, so it just give the information that there is three different sensors sending different information. So it will say that, okay, at this time, this is the humidity, temperature, and pressure. Okay, on the other time, if I just explore it to here, there are 5 or 6 different sensors, right? So each sensor is sending different data. You'll see that it's all like mutually exclusive, the field. Okay, this is magnetometer. Okay, this has the magnetometer data. The other will be empty. This has accelerometer data. The other will be empty. Okay, so then what I did was in the logic, what I did was I just want to extract all of these. It is not the best way that I've written the query, but I was just doing a demo. Okay, so what I did was I just did this. Okay, so I did this, comment it out, but I just say select the data from the IoT hub and put as a metric, which is called air quality. Okay, then I just say magnetic data. Okay, the air quality was the humidity, temperature, and pressure. The magnetometer was another sensor. Accelerometer was another data, and I just put all of them together. And then I just created some min, max, and this pressure value on a particular window. So I was just saying that, okay, for this particular duration, aggregate everything by 15 minutes and tell me how the fluctuation is happening. So when I was putting into a dashboard, you can see here in the output, I created 1, 2, 3, 4, 5, 6 data sets. Each one was showing on a different dashboard. Okay, I will run it. I hope it will work, but I'm not sure if it will be connected or not. Okay. And then here, I'm also sending it to a database, the real-time database, as I was explaining to you. I will start the job. Let's see. Okay. Started it. And then I'll see. Actually, because some of my credentials and everything, if I open it, it will have my other data and it will be recorded. So that's why I don't want to share that. But believe me, once you have this concept, you will be in a better position to do this IoT streaming and the analysis accordingly. Okay. Now, questions? Any questions?
Not a question, it's a request. I will see how you are registering your sensor in this IoT.
Yeah. Okay. IoT hub. Okay. So if I go here, okay, IoT hub, the devices which can most of the devices like the industry IoT, I will show you in the breakout. I will show you the IoTs that we have there. Okay, but you can see this device management devices, and then you will just get a device registration, and then you will get an authentication key. Okay, and you will have that in there. So if I just say add device, okay, you will just give this is my industry IoT one. Okay, then I'll just connect this. I will save this. It will give me an ID, and then the configuration of that. There is a gateway configuration and everything. And as I mentioned, that the hardware side is very difficult for me because I'm not directly on the hardware things. But the gateway, if you require this, I'll just send you some videos. It will be very easy to configure it. Okay. Yeah. But you just get the devices from here, and then you can send the updates and manage those devices accordingly as well. You will just say that send this reset command to this device, update the firmware of this device. You can do this kind of mechanism with the device management accordingly. Okay.
So Shah, in that case, we have accredited devices to control from the IoT.
Yes, there are devices who are already like accredited and things like that, but mostly the IoT devices, there is like one protocol or something, which as far as most of our devices are compliant to that, it will be very easy to do it.
So it's supposed to support a protocol in order to work here.
Yes. There are a lot of things that can be done accordingly. Yeah.
I think recently, if you have Arduino, you cannot transfer your data to the hub, to IoT hub, because you need a specific certificate for this one. Recently, Microsoft recently have updated this one. Before you was
because
able
of
to
a lot of
transfer
security things initially, when this device was initially approved in IoT Central, but then afterwards, because of security reason, this company didn't comply to the security standards, and that's why they are in there. But there's a lot of security things that companies are asking that we cannot do, like bypassing these security protocols, and that's why everything is hard. So for demo purposes, it's easy, but for real information, then it becomes a bit hard because you have to look into security, you have to look into connectivity, you have to look into latency, and it become like a bit more challenging in there.
You have any concern for the sensors which is coming from China?
So as far as they are like sending the data, and the some of the sensors are approved by a particular, let's say, government agencies and things like that, then yes. But you can say that, for example, if this sensor is in my room, and let's say I'm in a secure environment, okay, it can, let's say, sense my voice and things like that. But then what about this IoT device? It's hearing for everything, right? So so where would you stop it, right? So it's up to you. Like if sometime in a government secure environment, of course, they would like to certify this, and there are like then government rules and regulation that it's not just about like one country or another country. It's about the ethics and the things like that. And then these are companies who validate that this is like ethical, let's say, device for this purpose only, not something like spoofing or anything like that.
Okay, regarding to the security, how we are handling this one, because you have partner and you have customer. The partner who is doing this work, some kind of sensors and so on, and you have the end customer. Actually, who is going to consume this data. How Microsoft handling this problem?
So Microsoft as such, because there is different things, right? Like as I mentioned, there might be like IoT sensors for agriculture. Okay. Now agriculture data is just for helping the farmers to like produce or provide how much moist or water you need to give to your land. Okay, but if let's say the country, let's say if you put that sensor everywhere in a particular country, let's say in here in Qatar, and now that data is used for let's say some other purpose, or you know the environmental area of this, how the land is, whether it's fertile or not, and that is used for something else, that is not Microsoft things. We are providing the technology, and then it's up to the consumer and the scenario, how they want to consume that or share the data, it's up to them. But Microsoft is just providing the platform. If you have a device, you have a use case, you bring the device, we will provide you the ingestion and the data, and then the security layer, how to secure it. But if you want to share that data or with your consumer or your partners, you control the security. We just provide you the tools how to do it securely. But then if that data is not supposed to be there or something like that, that is not with Microsoft. I hope that answered the question. Yeah.
Sure. Do we have a page, how to start, or a quick start page that you can share with everyone if they want to start working on the IoT devices, how to integrate it into their solutions, their projects?
So the first thing I would suggest that you look into the stream analytics one, okay? The stream analytics that we have, that has a very good solution. Like, for example, it will give you an example. Previously, it was very easy to do the data extraction or tweet extraction from Twitter, okay? And then you can do sentiment analysis. You can have like a different type of tags that I'm monitoring this these tweets about Qatar or something like that, and you just retrieve that, you take an action accordingly, okay? Those will give you a better idea how to use it. But now some of these platform has also restricted, right? Because X is not exposing the APIs and things like that. So you can do your own simulation. Like in the examples, there is like stock monitoring as simulation. So the system will create some dummy data, but you can just see how the stocks are going up and down. You can take action that when the stock has gone up according like to this one, buy it. If the stock has gone down, sell it. As an example, so people can take this up kind of agent mechanism and do this kind of triggers as well. Okay. Or for example, if there is a bike hiring example, we have a lot of like the scooters, right? The electric cycles. So if there is like the IoT can send you the signal that this is broken, or there's a lot of people are looking for this one, this device, and we don't have the cycles nearby. So more cycles can be delivered accordingly. So there is examples in here. I can then post it on the WhatsApp, and then you can look into it. I'll ask a few questions now, okay? If you allow.
Sher, are we done from your side? I'm gonna stop the.
Yeah, almost yes. Almost.